Good morning. Now we are going to look into the lecture number 5, problems in effect of slip on rotor parameters and the relationship between torque and power factor. Okay. Whether the slides are visible? Anyone? Slides are visible? Anirudh?
Yes, sir. Yes, sir.
Okay. So in previous class, that is by hour number 2, have discussed what are the 5 parameters are there in slip. First one is rotor frequency, that is Fr. Second one will be the magnitude of rotor induced EMF, E to R. And third one will be the rotor reactance, X to R. Fourth one is rotor power factor, cos phi 2R. Fifth one will be the rotor current, I 2R. Now by using these 5 parameters, we are going to solve this problem. Okay, the first problem, this is the first problem. A 4-pole 3-phase induction motor operates from a supply whose frequency is 50 Hz. Calculate A. The speed at which magnetic field of stator is rotating. B. The speed of the rotor when the slip is 0.04. 3. The frequency of rotor currents when the slip is 0.03. 4. The frequency of rotor current at standstill. Okay, first write given data. What are the given data are there? Pole, P equal to pole. Okay, and it will be a induction motor operate with the supply of frequency F. Yes, supply frequency will be 50 Hertz. Okay, next. These are the 2 parameter. Solution. First one, the speed at which magnetic field of the stator is rotating. Rotating means magnetic field of the stator. So what is the speed we are calculating in the stator? Ns we have to calculate it. What is the formula? Ns equal to 120 Fs by P. 120 into frequency 50 divided by pole 4. How much? 120 into 50 divided by 4. 50 divided by 4. What is the answer? 1500 RPM. Okay, 1500 RPM. Second one. Second, the speed of the rotor when the slip S equal to 0.04. So in second subdivision, the slip value will be 0.04 is already available. Now we are going to calculate speed of the rotor, Nr equal to how much? So we know the formula, slip value S equal to Ns minus Nr divided by Ns. Okay, divided by Ns. Which is equal to S value 0.04 equal to Ns 1500 minus Nr divided by 1500. So you do the calculation, 0.04 into 1500 which is equal to 1500 minus Nr. So 0.04 into 1500. 60 you will get it, which is equal to 1500 minus Nr Therefore, NR equal to 1500 minus 60. 1500 minus 60, which is equal to 1440 RPM. 1440 RPM. Okay. What is the third one? The frequency of rotor current when the slip is 0.03. 0.03. That is my third one. The frequency of rotor current. Third subdivision, frequency of rotor current. That is Fr equal to how much? S equal to 0.03. So we know that the frequency of rotor current Fr equal
Sir?
yes. Tell me, ma.
Sir, we have already done this problem in the previous class.
Yeah. Wait. Some more students I am having doubt. That's what I am solving this problem. Okay. Fr equal
Okay, sir. Okay.
Fr equal to S into Fs. S value 0.03 into Fs value 50. 0.03 into 50. It will be 1.5 RPM. Fourth one. What is the fourth one? What they are asking?
Rod, sir.
Huh? When the frequency of rotor current at standstill, that is equal S equal to 1. So Fr equal to S into Fs, which is equal to 1 into 50, which is equal to 50 into 50 into hertz. Okay, this one. This one will be 0. It will be 1.5 hertz. Okay. Now we will switch on to the second problem. The second problem is the problem number 2. One second. The second problem will be the frequency for a 4-pole 3-phase 50 Hz induction motor on the stator turns. Okay, on the stator turns. For a 4-pole 3-phase 50 Hz induction motor, ratio of stator to rotor turns is 2. On a certain load, the speed is observed to be 1455 RPM when connected to 415 volt. Calculate the frequency of rotor EMF in running condition. B. Magnitude of induced EMF in the rotor at standstill. C. Magnitude of induced EMF in the rotor under running condition. Assume star connected stator. Given data. First we will write the given data. Given data. P equal to 4. Frequency Fs equal to 50 Hz. And stator to rotor turns will be 2. Stator to rotor turns will be E1, okay, and the rotor turns per phase will be E2, okay. This E1 stands for stator turns per phase, and E2 stands for rotor turns per phase, which is equal to E1 by E2, okay. E1 by E2 equal to 2, okay. E1 by E2 equal to 2, and on certain load the speed is observed to 1455 rpm, that is NR equal to 1455 rpm when connected to 415 volt. 415 volt will be phase, okay, E phase in stator, because stator only we are giving input, okay. E phase is nothing but we can write E1, okay. E1 will be, it will be in phase line. E1 phase is equal to 415 volt, okay. Now solution. Solution. The first one, the frequency of rotor EMF in running condition, okay, that is the value. Frequency of rotor EMF in the running condition, you are going to calculate it. That is, you are going to calculate FR equal to S into Fs, okay. Now we know Fs equal to 50 Hertz we know, but slip value we don't know. So how to calculate slip? S equal to Ns minus Nr by Ns. So Ns value we don't know. How to calculate Ns? Ns is equal to 120 Fs by P. So 120 into 50 divided by 4, you will get 1500 rpm. So S equal to 1500 minus Nr is already available in your problem. 1455 divided by 1500. That is slip. Therefore, S equal to 0.03. You will get it in terms of percentage. You have to multiply it with 100 because the slip value always represented in terms of percentage. 0.03 into 100, you will get 3%. Okay, you will get 3%. Now please substitute this value here. Fr equal to S value how much? 0.03 into supply frequency 50. So what is the answer? 1.5 Hertz. Okay, 1.5 Hertz. Okay. Next, second solution. Magnitude of induced EMF in the rotor at standstill. Magnitude of induced EMF. Induced EMF notation will be at standstill. Induced EMF notation will be E. Okay, E2, EMF will be E2. At standstill will be E2 in rotor. E2 you are going to calculate it. So how to calculate E2? What is the formula? We know that this E2 value, E2 we have to going to calculate, okay, in the rotor. Okay, so we know that the phase voltage, okay, we know the machine will be running in star connector, because in the problem itself they have mentioned it will be a star connector. Star connector means we know the line voltage is equal to √3 into V phase, or we can say notation. E also represent in terms of voltage. E line is equal to root 3 into E phase. Okay, E phase we are going to calculate it, but we don't know the E phase value because only line voltage only available in your problem. So E phase equal to E line. E line how much? It will be 415. 415 divided by root 3, because in your question they have mentioned the machine operated, it will be connected to 415 volt supply. 415 volt supply, it will be a line voltage. Okay, 415 divided by root 3. Okay, 415 divided by root 3, you will get 239.6 volt. Okay, so we know the transformer ratio. We know transformer ratio K equal to E2 by E1. This is the transformer ratio formula. E2 will be a rotor turns per phase divided by E1 is stator turns per phase. So which is equal to, okay, which is equal to, we can write E2 in terms of phase voltage, right? The rotor turns per phase divided by E1 phase. What is the rotor turns per phase by stator turns per phase by rotor turn per phase? In your question it will be 2 which is there, but actual formula it will be rotor divided by stator, but in your question it is stator divided by rotor, so it will be 1 by 2. Okay, in the problem itself they mentioned the ratio of stator to rotor turns will be is 2, that is it will be 1 by 2. Okay, so E2 equal to 1 by 2. Okay, therefore E2 phase is equal to 1 by 2 into E1 phase. E1 phase means this is, okay, this is 229.6. 1 by 2 into 239.6. You will get 119.8 volt. Okay, till now you have doubts? And third case will be magnitude of rotor induced EMF in running, that is you are going to calculate E2R. E2R stands for running. What is the formula for E2R? Any doubt? Anyone? Register Bharat is there? Bharat.
Yes, sir.
What is the formula for E2R? What is the formula?
I don't know.
You don't know. Last class you have attended, right?
No, sir, it's 7 about execution.
What is the E2? Grishma? E2R. Anirudh E2R. Anirudh is absent. Register number 61. 17. Register number 17. E2R equal to S into E2. So S value will be 0.03 into E2 will be 119.8 volt. You will get 3.594 volt. Okay, 3.594 volt. 3.594 volt. Okay. Next, third problem. A three-phase induction motor having a star connected rotor has an induced EMF of 80 volt. between slip ring at standstill on open circuit. The rotor has a resistance and a reactance per phase of 1 ohm and 4 ohm respectively. Calculate current and power factor in slip ring of short circuit and slip ring are connected to star connected rheostat. Given data, what is the voltage? Induced EMF voltage, it will be line voltage. Okay, so standstill of rotor, induced EMF. Okay, induced EMF, it will be 80 volt. So E2 equal to, it will be a line voltage, right? 80 divided by root 3. We'll get 46.2 volt. Okay, 80 divided by root 3. Because a machine will be connected in star connection. In star, line voltage is equal to root 3 into phase voltage. Okay, line voltage is equal to root 3 into phase voltage. So line voltage only available in your question. 80 volt, it will be a line volt. Okay, divided by root 3, you will get phase voltage E2. Okay, phase voltage E2. This is the standstill of rotor induced EMF per phase. 80 divided by root 3, you will get 46.2. The first one, A part. Slip rings are short circuited. Calculate the current per phase. So how to calculate the current? We know that current formula I2, because it is standstill, right? Okay, I2 is equal to formula E2 by Z2. Okay, E2 by Z2, which is equal to, E2 value is already available, 46.2 divided by Z2 we don't know. How to calculate Z2? Z2 equal to the magnitude of induced EMF is equal to square root of R2 square plus X2 square. So square root of R2 how much? 1, X2 is 4. 1 square plus 4 square. You will get 4.12, the unit of impedance ohm. So substitute here 4.12. You will get 11.2 ampere. Okay, this is the current. Okay, next power factor. Power factor is cos phi 2. Cos phi 2 formula R2 by Z2. So R2 value 1, resistance 1, Z2 4.12. We'll get 0.243. Okay, 0.243. This is A part. Next, B. Now the machine it is in running. Okay, now the machine it is in connected to star connected. The reason is that you see in your question the slip rings are short circuited. When the slip rings are short circuited in the rotor, the phi value we are getting will be 0.243. Okay, if power factor will be low, if cos phi is low, then the starting torque, this is one more question, starting torque of the machine is also be low. Okay, if power factor is low, then starting torque is also be low in slip ring. Okay, while you come to increase, how to increase the power factor? For that we are connected star connected rheostat of 3 ohms. So star connected rheostat means already we know R2 equal to already 1 ohm we know. Okay, now I added to 1 ohm Okay, added to 1 ohm, we are adding 3 ohms in your question, because already 1 ohm is there in your question. Here 1 ohm is already there. Now we have to add additional 3. Why we are adding the rheostat value? That is why we are adding the resistance value in the rheostat, means to improve the power factor. Once you improve the power factor, automatically the starting torque is also be increased. So 1 plus 3, you will get 4 ohms. So then we have to calculate I2. I2 equal to E2 by Z2. So E2 value is already available, 46.2 divided by Z2. How much? Z2 we don't know. So Z2 equal to square root of R2 square plus X2 square. Square root of R2 already 4 square plus X2. How much X2? It will be 4 square. You will get 5.66 ohm. Now substitute 5.66. You will get 8.16 ampere. Okay, 8.16 ampere. So in the similar manner, we have to calculate cos phi 2. Cos phi 2 equal to R2 by Z2, which is equal to R2 value will be 4, Z2 value will be 5.66. So 4 divided by 5.66, 0.707. Okay, so you see the here. Okay, here in previous division, if you are getting cos to phi value, because when we add resistance equal to 1, you are getting power factor very low value, you are getting very low power factor. Okay, that's what we are getting, the low torque. That is the condition. Okay, now if we add the resistance value to already existing value, you are adding resistance value with the existing value, that is 3 plus 1, you are getting adding 4 ohms in the rheostat. Once you add the 4 ohm, the power factor will be increased. Okay, power factor is high. Okay, once we are increasing the power factor, automatically the starting torque is also high. Okay, okay, power factor is high, starting torque is also high. Are you understand? Are you understand it?